So today I'm going to show you how to solve fluid static problems, which break down into basically Pascal's principle and Archimedes' principle problems. So let's start off with Pascal's principle. So for Pascal's principle, we have only one equation. Force in over area in equals force out over area out. So if I read this problem, a nurse applies a force of 4.40 newtons to the piston of a syringe, which has an area of 5.00 times 10 to the minus 5 meters squared. So that gives me the force on the input and the area on the input. So I know everything there on the left-hand side of the equation. If a needle with an inside diameter of 0.413 millimeters is used to deliver the fluid, so that's the diameter of the output in millimeters. Remember, I've got to divide by 1,000 to convert that into meters. So I get 4.13 times 10 to the minus 4 meters. And using that diameter, I can find the area of the output, because remember, for a circle, the area is pi r squared. So that's pi times the diameter over 2 squared. Right? And this is an equation that I'll expect you to know. I will not give it to you on the test. It's sort of basic geometry, which you should know from high school. All right, so I can sub in my diameter, 4.13 times 10 to the minus 4 over 2 squared, and I get a very small area, 1.3396 times 10 to the minus 7 meters squared. And I'm not going to round this off at this time. Okay, so now I know the area on the output. So I know all three things in the equation that I'm not asked to find. I'm asked to find it with what force does it exit. So the force out over the area out equals the force in over the area in. So rearrange it to get force out. I just multiply both sides by A out. So force in over area in times area out. And I know all those numbers, so now I just plug them in. So 4.40 newtons. Area on the input is 5.00 times 10 to the negative 5 meters squared. Area on the output is my small number, 1.3396 times 10 to the minus 7 meters squared. Okay, so you can see the meter squared units will cancel out and leave me with newtons. So the force on the output is 1.1789 times 10 to the negative 2 newtons. And now I need to look at my number, round it off to the correct number of significant figures, which looks like it's 3 based on the numbers given in the problem. So 1.18 times 10 to the minus 2 newtons. So the fluid that goes into your arm when you get an injection is actually got quite a small force, and that's why it doesn't hurt very much. Okay, so now let's do an Archimedes principle problem. So for Archimedes principle, what we know is that an object that's in a fluid feels lighter because of the buoyant force pushing up on it, and that the apparent weight of the object will be equal to the difference between the weight downwards and the buoyant force upwards. So in this problem, you're going fishing, and it tells you the fish weighs 200 newtons in air. So if we look at the picture, the weight downwards, mg, is 200 newtons, and the net weight when the buoyant force is subtracted is 15 newtons. So I know that the buoyant force is going to be 15 newtons less than 200. Or 185 newtons. Okay. And in water, the density of water is 1,000 kilograms per meter cubed. So if I look at my equation in blue there, I know my buoyant force, I know the density of the water, I know what G is, so I can find the volume of the fish is the buoyant force divided by the density of the water, and divided by G. So the volume of the fish is 185 divided by 1,000 divided by 9.8. And I get that the volume of the fish is 1.888 times 10 to the negative 2, and the units for volume is meters cubed. Okay, so now I know V. So what are they asking us to find? They're asking us what's the density of the fish. So now I'm going to use the equation in red. The density of any object is its mass divided by its volume. And I just found the volume. Do I know the mass? Well, what I know is that the weight of the fish, which is mg, is 200 newtons. So the mass is just 200 over 9.8. It's going to be about 20 kilograms. In fact, it's 20.41 kilograms. And again, these are intermediate numbers. I don't round them off. All right, so what's my final answer? My final answer is that the density is mass over volume. And so now I just put in my numbers that I calculated. 20.41 kilograms over the volume, 1.888 times 10 to the minus 2 cubic meters, and I get 1,080.9 kilograms per meters cubed. And I gotta go to, let's see, looks like 3 significant figures. So 1,080 kilograms per meter cubed. Okay. So another thing is that looks like a big number. Does it make any sense? Well, if you look, the density of water is 1,000. So this number is actually just a little bit bigger than that of water. And that makes sense because the actual apparent weight of the fish when it's in the water is very little. It's only 15 newtons compared to its actual weight when it's in the air. So that tells you that its density is very close to that of water. If it were the same as water, it would have an apparent weight of 0. If it were a lot more dense than water, it would feel a lot heavier. So this number makes sense. So both of these kinds of problems are fair game for the test. You'll see either one or the other. So make sure you can do either of them. So with that in mind, I've given you one Pascal's principle problem. And be careful when you solve this problem. The force is applied from the right. So the force in is actually coming from the right side, and you're asked to find the force on the output. And the second problem, you've got a brick resting on the bottom of a pool, and you have to figure out what's the net force. So what force do you need to lift it from the bottom of the pool?